lesson 7.1, we are specifically looking at a special type of parallelogram, a square, and a rectangle. So question number 2 is about the square GKJH. And segment GK, this side here, is congruent to the other three sides of the square, since all the sides of the square are congruent. That would be segment KJ, segment JH, and segment HG. And number 4, we're looking at angle GEK. GEK is this angle, and because a square has diagonals that are perpendicular, all 4 of these angles are congruent to each other, and all 4 are 90 degrees. So this angle is 90, 90 degrees, 90 degrees, and 90 degrees. So let's start naming them. KEJ, JEH, HEG, and then in addition, in a square, all 4 angles in a square are also right angles. So we're going to list all 4 of those. So angle GKJ, KJH, JHG, and HGK. Number 6 is referring to segment GE, and because a square is a parallelogram, the diagonals do bisect each other, and also in a square the diagonals are congruent to each other. Therefore, GE is congruent to EJ, which is also congruent to EK, and also congruent to EH. Number 8 through 13, the diagram is a rectangle TM and U. So we need to think about the properties of a rectangle, and specifically in number 8, we're looking at segment MN. Segment MN is congruent to segment TU. And segment MT is congruent to segment NU. Angle MTU is a right angle, angle MTU. It is congruent to the other 3 angles in the rectangle. congruent to segment TN, the second diagonal. The diagonals in a rectangle are also congruent. Right, in the diagram on the right, segment BD segment BD is congruent to segment DF. Which is also congruent to segment BH and segment HF. Also in the diagram, angle HAB is a right angle. And we can see in the diagram there's a right angle here in this corner. Angle BCD is also a right angle. Angle DEF is a right angle. And angle FGH is a right angle. So we need to classify a couple of different quadrilaterals. The first quadrilateral is HBDF. Is a rhombus, and the reason why we know that that is a rhombus is a rhombus has four congruent sides. The second quadrilateral we need to classify is quadrilateral ACEG. This quadrilateral has four right angles, so we say that it must be a rectangle. We can't say it's a square because we don't know if all the sides are congruent, but at the very least we can say it is a rectangle. So what can we say in part B about lengths of the diagonals? AE and GC is we can say that those diagonals are congruent because they are the diagonals of a rectangle. And then what can we say about segment AJ, JE, CJ, and JG? Is that they are all congruent to each other. Because in a rectangle, the diagonals bisect each other. rectangle ABCD. And to help me answer these questions, I'm going to sketch over here on the right. I'm just going to sketch a rectangle and label it A, B, C, and D. All right, we need to decide if each of these statements are always true, sometimes true, or never true. So let's start with angle A and angle C. Are they congruent to each other? Yes, in a rectangle, all angles are 90 degrees. So that is always. I'm going to put the letter A for always. Segment AB is congruent to segment CD, and that is true in all rectangles. Opposite sides are congruent always. And AB and BC can sometimes be congruent if that rectangle happens to be a square. So we do have special types of rectangles where all four sides are congruent, and so that happens sometimes. A rectangle is always a parallelogram. A square is always a rectangle. A parallelogram is sometimes a rhombus. Sometimes the parallelogram could be a square. Sometimes the parallelogram could be a rectangle. So in number 20, we have a diagram of a square, and it says to find the value of the given variable. So we're looking for the value of x. And what we know about the angles in a square is that they are each 90 degrees. So therefore, I can say that 5x must be equal to 90 degrees. Number 22, since each of these angles in a rectangle are 90 degrees, I can do a number of things. I can first say that x plus 40 must be equal to 90, or I can say that 2x minus 10 must be equal to 90, or I can actually say that these two angles, x plus 40, must be equal to 2x minus 10. Any way we set up the equation, we're going to get x is equal to 50. And in number 24, since we have a diagram that is a rhombus, what we know about a rhombus is that all four sides are congruent. Therefore, side UW is congruent to segment YW. So to find the value of x, I can say that 3x is equal to x plus 2. All right, Lisa is trying to prove a particular property about squares, and that property says that the diagonals, highlight those, the diagonals bisect vertex angles, which means these diagonals cut these two angles exactly into two congruent parts, two congruent angles. So that's what she's trying to prove is that these angles are bisected or congruent to each other. To do that, to prove that, she is going to prove in her proof she can prove that, then she can say that these two parts, which are corresponding parts, and if she can prove that those two triangles are congruent, then those two corresponding parts are also congruent. So in her proof, she needs to prove that triangle AED is congruent to DEC. So let's see if we can help her out in her proof. So I'm going to leave these two checked so that we know which two triangles we're trying to prove congruent. So here's what I know about a square. I know that all the sides in a square are congruent. So I can now say that segment AD is congruent to segment DC because all sides in a square are congruent. Right, so here's what I have right now. I have one pair of congruent sides. I need two more things. What I also remember about squares is that the diagonals are perpendicular to each other. So we can say that AC is perpendicular to DB by definition of a square. Or it might be better just to state in the definition of a square we have 4 congruent sides and 4 right angles. So let's just say because no, I don't like that either. Let's try this. Let's say that angle AED and angle DEC are right angles because the diagonals of a square form perpendicular lines. So we listed a pair of sides that are congruent. Now we have a pair of angles that are congruent. And then I can finally say that side DE is a common side in both triangles. So therefore, segment DE is congruent to segment DE by the reflexive property. So that gives me another pair of sides. But in looking at this proof, let's just get these two little checks out of the way. In looking at the proof, I have angle side side, and I know I can never use angle side side as a way to prove that triangles are congruent. But because I have right angles, I can say that these two triangles here are congruent to each other by hypotenuse leg. Because they're right triangles, they have one pair of hypotenuses that are congruent and a pair of legs that are congruent. So I can now say, like Lisa said, that these two triangles, triangle AED now use CPCTC to say that, finally, these two angles are congruent, and therefore they are bisecting. All right, let's try to arrange these four quadrilaterals in a family tree so that we can see which properties take on characteristics of other properties. So what we notice here is that all three of these figures, all three of these, rhombus, the rectangle, and the square, all of these belong to the family of parallelograms. All right? Now, in addition, a square has properties of a rectangle, and a square takes on properties of a rhombus as well. So, we can say that a parallelogram has all three members in their family, and so a parallelogram can be a rectangle, parallelogram can be a rhombus, and because a square is both a rectangle and a rhombus, then we can set the family tree so that it looks like this.